Hello, everybody. Thank you so much, and welcome to the C++ Meetup at Woven by Toyota. It is now 6:30, so we will go ahead and get started. First of all, thank you so much for joining us today. We love being a part of building and connecting the C++ community in Tokyo, and we're thrilled to have everyone here tonight. Tonight's event is going to be a mix of a panel discussion and a Q&A, and our panelists will kick off a brief discussion of today's main topic. And we welcome anyone in the audience to ask a question by lining up in the middle, grabbing a microphone, and asking your question when it is your turn. あと、日本語を喋る方は、日本語でも質問聞いても大丈夫ですので、途中で何か日本語の質問があれば、真ん中に並んでいただいて、自分の場になったらマイクロフォンを取って、そのまま日本語で質問聞いても大丈夫です。一つだけ同時通訳者がいますので、なるべくちょっとゆっくりめで説明していただいて、皆さんに通じるようにお願いいたします。よろしくお願いします。Okay. With that, I would like to jump right into it and welcome our amazing panelists to the stage. So panelists, if you could please come on out. All right, thanks for joining us. All right, thank you so much. So rather than listen to my boring voice all night, let's jump into having the panelists introduce themselves, starting from the end, the far end, please.
Hi, I'm Charles. I've been working on C++ for about 10 years, starting with my time as a theoretical physicist, where I did black hole calculations in C++. At Woven, I work on foundational C++ libraries for safety-critical code.
My name is Jason Turner, and I don't know, you said how long you've been programming in C++. That makes me have to question now. I think I first touched C++ almost 30 years ago. That can't be right. Oh well, anyhow, I do training and consultation, code reviews, that kind of thing, and I have a YouTube channel, and if anyone wants some, I have some stickers that I brought with me from my YouTube channel. Don't forget to grab some from me later today.
Cool. Hi everyone, I'm Adam Panzika. I'm architecture lead on Arena SDK engineering. I've been doing C++ professionally for, God, is it 14 years now? Getting old. And programming C++ for maybe like 17, 18 years. I spent most of my career around the automotive industry, so here or in the self-driving industry at Uber and Argo.
Hello. I'm Jessica Paquette from the internet. I'm a compiler engineer. I've been working on LLVM, the compiler infrastructure, since about 2016. And yeah, happy to be here.
All right, thank you so much. Really appreciate it. Okay, so I will kick off the first discussion question, but like we said, as the panelists begin speaking, if you'd like to ask a question, we would highly encourage it. It makes this way more exciting. So please feel free to line up in the middle, and when you are at the front, you can go ahead and ask your question. So let me kick it off, and we'll get right to the point. Panelists, why should any C developer in the audience or anywhere consider switching to C++?
Well, the first thing that comes to mind for me is that C++ is a more strongly typed language than C. And so even if you're not using C++ features, there's a strong chance of, if you can just compile your C code with a C++ compiler, that you will find some type-related bugs that you didn't know were there, just by the compiler not letting you do some implicit conversions that are legal in C.
Yeah, I feel like that's probably going to be a consistent theme of things we talk about tonight, is like it can really help you push where you find issues earlier in the chain, right? Which is very important in many fields. And it makes it much easier to produce complex software in kind of an affordable way, right?
Yeah, I'd agree with that. I mean, in general, it's like C++ offers better abstractions than C, or more abstractions than C. If you are looking at your program and you think that you would benefit from maybe being able to represent things in a higher level way, then if you're going to rewrite your program or start writing new programs, C++ might be a good option for you.
I think those are all excellent points. But for me, the number one thing is the standard library. Because the C standard library, as probably many people in the audience know, is small enough that you can sort of implement it as like a sort of fun project if you want, or even just inside of a company, maybe you have a special need, you can just implement a C standard library for that. Some of the people in this room have done so. Whereas the C++ standard library contains a huge number of classes that are super useful, containers, lots of algorithms and things that otherwise you'd have to write on your own. And every C programmers, I think, generally believe and generally are mostly correct that they can write these things on their own, but every time you write new code, you make mistakes. So having those as a standard makes it easier.
And to your point, even just taking something like string manipulation, if you just want to literally concatenate two strings in C using the C standard library, that is several steps where it is one step that is taken care of for you in the C++ standard library.
Yeah. And I think especially on the dimension of safety critical coding, right? Like there are many rules in safety critical coding standards that originate in these lack of abstractions, right? And so the more that you can centralize where kind of difficult and easy to get wrong work is, the less likely you are to have to like make a lot of really esoteric rules that everyone then has to learn in order to avoid these problems. You can just use stuff and it works, right?
Sorry. I gotta put on my evil C programmer hat. So like, yeah, the standard library offers a lot to programmers, but it's also got a lot. It's got a lot of things. Like, and I've found that when I talk to C programmers, one of their main complaints is like, the language is really big and I don't understand all of it. They kind of lose the sense of control over what they're doing. They're not really sure whether or not the standard library or the language itself offers features that would help them.
Yes.
And I kind of wonder how to approach that kind of discussion with C programmers.
Yeah, I have an anecdote for this one, so if you mind. Yeah, so I think like I had a colleague once that I think really captured that really well, right? I was talking to them about something and they were like looking at some code that was written in C++. It was kind of a mix of abstractions and not. And they're like, man, you know, I really enjoy C because in C, like I know exactly how the computer is going to do everything that's there, right? Like I can read the code and I see how it works. Right. And that isn't always true in C++, right? But C++, you can start, it can become easier to express what like my argument back to him is like, yeah, but you can understand how it's working, but can you understand what it's doing? Right. Which is not the same thing, right? It might be the same thing in a local context, but as you get higher up in the system context, it becomes harder and harder to reason about what the program is doing.
Yeah, and well, anyone who's watched any of my presentations or my YouTube channel or been in my class like this week, I have the tendency to show Compiler Explorer windows and say, oh, look, the compiler is doing this, and we can look at the assembly, and we can understand this. But I have to admit that that's also just like, in a way, a false sense of security, in a way. And it's true for C programmers as well. So this isn't like a C++ thing. Because I've been to talks from people who understand the hardware better than I do, and out-of-order execution, and all of the things that our processors do when they rearrange stuff. And like, do you really know what the computer's doing when it executes your code? Do you?
Right.
Right, because like code isn't real, really. Like, I mean, like the code that you write isn't really a reflection of what's actually happening all the time. Like it gives you some sort of idea of what's happening, but like, you know, the semicolon isn't real, for example.
Right.
You know.
Yeah, that's especially true in older versions of C and C++, where there's no like clear memory model for multi-threaded code and things like that, and so you can often end up with just instructions getting reordered into places that you don't think they're going to be, and you have to be very careful about, you know, using all of these primitives that you can sort of abstract out if you're in C++, or modern C as well gives you the tools for these. But a lot of the times, if you're looking at production C code that people are writing, it's often on these very old standards that don't really have these tools built in, and so you have to go to the OS, or just it makes it more difficult to make sure all that stuff is doing what you want it to.
Right.
So, Jason, kind of, you have probably the most experience of all of us educating, right? So, what do you think when you encounter people? Because I think this like touches on a really interesting concept that I've thought sometimes about, which is like part of it is like appropriate levels of declarativeness, right? In C, because the language is so simple, you at every level of the code, the like level of declarity of what it is possible to express that is happening is relatively uniform, right?
Okay.
In C++, it's really easy to like mix very different levels of like declarativeness of the abstraction you're trying to conceive, right? You even had us do some examples in the training just a second ago, which is like you could have like a raw for loop sitting next to like a crazy ranges thing, sitting next to like some raw pointer manipulation, sitting next to like a dynamic allocation, right?
Right.
And that's really easy to do. So how do you like approach educating people on, because we might agree that that's bad in C++, right? And so how do you educate people on how to like make that transition and bridge that gap between the two?
So that's bridging the gap between like the lower level C and like starting to add higher level
Right.
abstraction.
Like how do you like organize so that that level of declarity at each level stays uniform, and then you can kind of have that same ease of understanding, right?
Right. So that, I mean, that's an interesting question, but I've never really, I guess, thought about it like that specifically. So I don't tend to have large groups of like C programmers in my class. Although there have been a few times when I've been brought into an organization specifically to convince some C programmers that C++ is okay and safe to use in the project. And so I've actually had programmers in my classes that say, I'm a C programmer and I hate C++, basically, and I don't want to be here. And so my job by the end of a couple of days is to convince them that it's okay to use C++ in your code. And I already mentioned that I like using Compiler Explorer and showing what the compiler is capable of doing. And I think what ultimately, so I'm going to answer a question that you didn't ask.
Sure.
Okay. But ultimately what I do when I am able to convince C programmers on the team that it's okay to use C++, it's okay to trust the compiler, is I show things like return value optimization that C can't do the same way. And like, yeah, it's actually like performant and safe and generates good code. It's okay to actually return a very large array from a function in C++, and it will do the right thing here because of return value optimization. Or I show in this template context with a callable parameter, and like a classic example from my perspective is C's QSort versus C++ standard sort. QSort has opaque void pointers into the data being sorted, and then it has an opaque function pointer into the comparison operator, and then it does QSort. Because of that, QSort is considerably slower than standard sort, where standard sort has a templated type on the type of thing being sorted and a templated type on the comparison operator. The compiler can see all the way through this, and not many, I mean, and sometimes it can even do this entire sort of compile time if it knows the data at compile time. So that's what I end up focusing on. Like, again, to answer the question you didn't ask, I focus on like how do these abstractions actually help you write better code than you could have with the techniques you were using in C.
And I was going to say that's a good for you because you actually work on compilers,
Exactly.
right?
Like I wanted to talk about Compiler Explorer because when I hear Compiler Explorer, I get really excited. So, but would you say that when you're talking to C programmers and trying to convince them, like in general, things like Compiler Explorer are enough to convince them, or
Almost
are they
always, yeah.
concerned about like language level differences as well? Because I know that there's like some weird foot guns between C and C++ where the languages aren't exactly compatible in one way or another. So like they might be a little bit worried that like, oh, I don't know, is the sideness of this type the same? If I start writing code in this way, is it going to break my mental model? Like, how do you approach that kind of thing?
It doesn't tend to be the concern of the programmers that end up in my classes.
I see.
The concerns that I have to address is I can't trust this high-level thing because it will be slower. And I show them with Compiler Explorer that it's actually faster than what they were doing in C. And then I usually get pretty good traction with that.
Would you say that they have like concerns about other metrics as well? Like runtime performance is obviously very important to a lot of people working on C working in C because they're usually working in environments where there's some serious constraints on how quickly things need to run. But also sometimes people working on C projects are very concerned about code size, for example, or they're very concerned about just developer productivity in general. When I've talked to C programmers, they're in general their main complaints are C++ is bloated, C++ is slow to compile, C++ is this and that. I can see how Compiler Explorer can help with proving runtime stuff, proving code size stuff. What about other metrics like compile
it's just
time?
not the kind of thing that I've personally really, because it's in my situation, if someone's going to hire me into their organization, it's at the very least the team lead wants to get everyone on the same page and they know who I am, basically. So it's always like some portion of the team at least is already in C++ and they really just want to get some subset of the team more up to speed with us. So what you're asking is simply I just don't have experience with that is what I'm trying to say. I have experience with convince the last couple of people that it's okay, you can trust the compiler.
Right.
And I show them, yes, you can trust the compiler. And sometimes this even comes down to like unique pointer. And Compiler Explorer really is great at this. I can show unique pointer usage and I'm like, look, it's doing a new and then a delete exactly like you would have.
Yeah.
Right.
Or I can show them vector and I can say, look, it's doing a new, copying the data into that memory location, and then it's doing a delete of the objects there, exactly like you would have done. And that is where I gain the most traction with my students.
Have you used things like optimization remarks before?
I have not.
It's pretty useful for showing people like what the compiler is doing to optimize the code. Like rather than just like I wrote some code and then magically I get like, oh, return 0. How did I get there? Something. And then you can actually get like a record of every single thing the compiler did to detect that it could actually perform that optimization.
So for people who are not familiar, what are
and people who are really afraid.
No. What are optimization remarks?
So optimization remarks are it's a way for you to tell. It's in Clang, so it's kind of compiler vendor lock-in. I think GCC has some support now. I'm not a GCC person, so don't quote me on that. But the idea is like the compiler is kind of a black box, right? Like it makes code fast, it makes code small, it does whatever. It inlines stuff, it outlines stuff, and then weird things happen to your code and you don't know why. So the idea is whenever the compiler does something or decides not to do something, we're going to have a diagnostic that comes out and says like, in this function, we inline to this function into this function because blah.
Right.
These can also be stored in like the binary in some for like I think for Mongo
debug symbol kind of thing.
Yeah. And then you can go and get a big record of it. But in Compiler Explorer, you can actually enable optimization remarks, and you could actually like highlight the lines, and it's like here's how this was optimized and when it was optimized, or here's how this wasn't optimized.
So to your point, one of the like fun about the like and it's like related, right? It's like not trusting what the compiler is doing and why. But one of the things I found really interesting is I to like a zero cost abstraction kind of thing, right? I once manipulated some C++ to add like an additional abstraction that I was like, I don't know if this is going to be like as efficient as the more raw thing I was doing before. And I compiled it. And Bazel, the build system we use, the test, which is cached and it only reruns if the binary changed, didn't rerun.
Oh.
Because it detected that the binary was identical, right? Like the compiler had optimized it to the exact same code that was there before. And so it was like, cool, this hasn't changed, don't need to rerun the test, right? Yeah, right? Like as like a case point for like zero runtime cost abstractions, right?
Panelists, I'm sorry, let me just jump in for 1 second.
Oh, Nick's getting bored.
No, I'm actually, I'm lost, but I'm not bored. Thank you. I just want to remind everyone that we are also here to answer your questions too. So I know it's the hardest and most awkward to go first. We've all been there. But if anyone would like to ask a question to the panelists or say, how would I handle this situation? Hop up. I promise nobody bites. Thank you.
Please troll us. Please troll us.
We've got a C-man here.
Yeah, I've been spotted. Yeah, let me open the question round. I'm from Woven. The subtitle of the meeting is Abstraction for Low-Level Programming.
Yep.
So for me, low-level means writing kernel code, writing a bootloader, writing a trusted application, running in ARM Truston, for example. And one common denominator of those, it's often C, but also I don't even have the standard C library. It's bare metal. So like a lot of arguments we went here was like, oh, the standard C++ library is great, but let's go back to the low-level programming where not even the libc is there.
Yep.
How would C++ be helpful in this low-level environment, bare metal, basically?
Sure. So I think one of the most basic and powerful abstractions that you get just as a language feature, you don't need anything else, or there's two of them, they're kind of related, is overloading and templates, right? Like, think of the amount of stuff often in C, you have to do some crazy macro thing to generate a bunch of copy-pasted code for your, like, types. Template just does that for you. You want to be able to call a function that behaves differently based on its type, like overloading, right? You don't have to know, like, I'm calling fabs for an int or I'm calling fabs for a float. You just call fabs, right? And so that can make even writing your own stuff easier, and you can still leverage like a lot of the type system stuff in a way that is just like not easily doable in C, especially when there's like implicit conversions and stuff all over the place.
Yeah, I mean, one common thing that you have to do in low-level code is just like mem copying things into and out of weird buffers somewhere.
Mm-hmm.
And if you're in C, you're going to have to do this with a void pointer and a size in bytes probably. And you can, it's just easy to get that wrong. Like, I'm sure there have been, like, just if you look at the list of vulnerabilities and not safety critical stuff, but like, you know, internet things, a lot of these are just stuff getting copied wrong. And like being able to use C++ allows you to have that type information available for you at compile time, and you can just, the compiler can just read everything off and make sure that it all matches. And it's a whole class of things you don't have to check for because it's just automatically right.
I think it would be a shame to miss the opportunity to bring up constexpr as well.
Mm-hmm.
Mm-hmm.
I know I don't do a lot of low-level embedded kind of work, but I know people who do, and they rely heavily on constexpr for generating things for them at compile time. Like, you know which processor features you want to enable, so you have a constexpr function that sets all of the bits and the bit mask that you need, and then at device boot time, you can do like a single write of all of the bits that you want to set instead of doing like 8 writes to set each bit or whatever. Like, I've seen like specific comparisons where they said, well, before we were doing it this way, now our boot up is, you know, 10 times less generated code because we pre-compute at compile time all the flags that we care about or whatever.
Yeah.
Well, yeah, I mean, that kind of thing.
And C has const expert too, but again, without overloading in templates, its utility can be like really limiting.
Oh, but C's const expert is only for variables. You can't make a const expert function.
Yeah. Right, and so like it reduces the utility of that like dramatically, right? You wind up with if defs everywhere to do the like equivalent of what you could just do with a few const expert functions and some templates and an overload, right?
And that's also C23, which I don't believe anyone is using yet.
No.
Yeah, it was in C++.
Hopefully the const function are coming in the next C, like the C23, as you said, just have the const variable.
Okay.
The C11 has the const, which doesn't mean to be const expert, like it's just, hopefully that's something coming next. But C++ for the concepts is probably like that's a feature in Vi.
That would be nice.
While you're up here, I've heard that a lot of C programmers really, really like the GNU style extensions. Is that true? What's your favorite?
My favorite GNU style extension is the compound expression macro.
I've heard that. I've heard that people really want like compound expressions and like just to use stuff in C. Like they want portable stuff from the GNU extensions of C quite a bit.
What is compound expressions? I need.
It's like if you want to put several expressions in a macro, like we do parenthesis, curly bracket, put your several expression,
Really?
and the last one will be the return value of the macro.
It's statement expers.
Yeah.
Yeah. Okay.
Yeah, like somebody brought that up on Mastodon when I trolled a bunch of people by mistake. And like, I guess something that people spend a lot of time doing is writing functions to like compare structs. And they're like, oh, I wish that every single compiler vendor was forced to implement this so that we could just write this macro every single time. And then it turns out that the macro they wrote was wrong, so it didn't really like do the thing. But like, this is something they really wanted.
But I think that's an interesting, to the point about C being compact, right? Sometimes it can be so minimal that you then wind up having to rely on all of these various compiler extensions. It's harder to get people to agree because one of the goals is to have it be so compact. In C++, even if you don't have a standard library, you still get a lot of things more built into the standard because they're more willing to, I think, sometimes expand what is the set of things that have to be like normatively complied with, for better or worse. For better or worse.
Well, I mean, you are still seeing movements in C to, like there are a bunch of current extension features that are being standardized in C, but it does tend to move quite slowly. Like I'm on the Japanese C standardization committee in the as a member of the ISO C standardization committee, and they've just like they're working on standardizing defer, which is currently available as a GNU extension cleanup, where you can just sort of say, here's a hook that I want to run when my code goes out of scope. This is a destructor that C++ has had from the beginning. And of course, those are also features that you can use that just are not standard library at all. You can also default the comparison operators to get that thing you were talking about with the struct. That's a language feature, doesn't require a library as of C++ 20 for that one.
Thanks a lot for the question. That was amazing. Really appreciate you coming up first. Is anyone else interested in asking the panel a question, or would we like to change topics to something new? Going second is much easier, I promise.
Come on up to people.
Yeah. 3 people willing to go second.
You guys can also make a line. It's okay. I'll make sure we keep it in a reasonable time. Go ahead.
Sorry to come again as another woman employee. One issue we usually have is we do low-level programming. I really want to make sure that my code runs real time and that nothing will come and interrupt it. And the issue is as soon as I use a standard library, most guarantees are kind of out of the window, and it could throw exceptions, it might allocate, we are not sure, and so a lot of people tend to throw away the baby with the bathwater and say no standard library in this part, and it's actually hard to verify one way or another, and so we end up doing drastic things. So do you have any advice on
So
compiler person?
Maybe you can talk about RTSync.
Yeah, Artisan came out, but I don't know a lot about it because I didn't read about the.
Okay.
But I know it came out, and it is for real-time environments. So.
Yeah, so this is, I don't know, again, this is like a really new thing, right? But one of the really cool things that just came out in Clang 20 is, and you can technically use it before Clang 20, but it gets a little more complicated, is a thing called real-time sanitizer. So for those that aren't familiar, there's a bunch of sanitizers, which are basically various runtime or static analysis tools that you can enable in your compiler to check stuff, more stuff than would be normally checked by compiler warnings. And so one of these new ones is real-time sanitizer. And real-time sanitizer, you can add annotations to your code that basically say this scope has to be real-time safe. And real-time safe basically means it can't make any like blocking system calls, right? It can't allocate memory, it can't lock a mutex without using time, et cetera, et cetera. And then it can do static analysis to basically show, does anything in the chain of a set of calls that's supposed to be real-time safe do one of these things it's not allowed to do? And it can just like throw warnings at you and say, yo, like based on static analysis, I know that this isn't going to work in a real-time system, right? And that can really help up-level like the type of things that are possible to do without having to resort to the drastic measures of like, let's throw away all of the standard library because we're afraid that like someone might accidentally call this one function that under certain circumstances that will never happen in my real-time system because I can't allocate memory in the first place, for example, I will throw like an exception, right? Or I'm worried I'll lock a mutex or something. Yeah, so that's, I think, like one of the things. But it's real. I mean, Charles is spending a bunch of time right now. Like that's a big part of the library stuff that we do, right?
Yeah, making sure, I guess, providing real-time safe libraries for everybody to use. This is something that is definitely possible to do in C++. As you've said, it is not automatic. And so I absolutely agree that there's a tendency to just say, I can't guarantee that that everything is going to be real-time compatible. So I'm just going to give up. But it is possible to do this, and sanitizers are amazing. If anyone is writing C++ code in the audience and is not using sanitizers, please use them all.
Yeah. I think so. LVM has this libc project actually, and I think one of the reasons that they wanted to write a libc, like they're writing a libc in C++. It's kind of weird, but they mentioned, oh, we want to use the sanitizers. Like that was one of the major reasons that they wanted to use, C++, I guess. So.
Right.
Yeah.
And some of those would just be very difficult to implement in C because you don't have well-formed object lifetimes. You don't have the places to go and annotate the things that are needed to track this stuff, right? But yeah, so hopefully that helps.
Yeah, thank you so much.
Thanks a lot.
Did we get awesome? And
Would like to make one.
go ahead.
Yeah.
Jason, go ahead.
Oh, sorry. Just one last comment as you walk away. It is documented which standard library things may or may not allocate and which things may or may not throw. So
Yes.
it is knowable. Like we treat it like a surprise, but it's definitely knowable.
Yep.
So for those of you who are strongly concerned about that kind of thing.
It is knowable, but there's not like a flag you can put in your compiler to say, please give me the standard library, but without all of the
That's
allocating
true.
stuff.
You can't do that, yeah.
Yeah.
However, we do all follow coding rules, coding guidelines that, say what you can and can't use. So.
Thank you. And I promise standing in the back, we'll definitely get to you next. So just hold on 1 second. Please go ahead and ask your question.
Hi. So I've been programming C++ for 30 years as well. I'm finding this discussion very interesting because all of the arguments and debates I'm hearing are exactly the ones I heard 30 years ago with the C people not wanting to go to C++ because it's slow, blah, blah, blah. I'm surprised that we're still having the same subjects now.
Yeah.
And I'm surprised that the issue of memory safety hasn't come up yet, especially because, of course, there's this new language on the scene.
We don't know what you're referring to.
And it's made me think very differently about C++. I've only been programming the new language for a year. I wrote a major piece of software, had 0 crashes. And when I went back to my home projects in C++, I realized I was spending 3/4 of my time debugging in C++ and only 1/4 cutting new code. And a good example of this, I'm aiming for retro systems like Amigas with no MMUs. You know, I forgot to put a move constructor in. 2 hours I'm hunting for this because it was pointing to memory on the stack. And of course, it might crash after 30 seconds, it might crash after 2 minutes. The call stack had nothing in it that gave anything. And so, of course, this is my fault. But even with 30 years of experience, you can forget the move constructor. So, of course, the new language, it wouldn't let you forget the move constructor. That'll get it at compile time. So what is your opinion about adapting and improving C++ so it doesn't let you make these mistakes to begin with in relation to memory safety?
Layers of tooling. Like the example that you specifically just gave, if you were running cling tidy with its rule of 5 check, you would have gotten an error at compile time. So
at static analysis time.
At static analysis time, yeah. So you've got to enable every single, just do it. And I don't mean -W everything on Clang, because that can be hard to sift through, but so many warnings, enable them all. Make warnings as errors. Half of the people in the room are going to dislike me for saying that. Warnings as errors. Static analysis with warnings as errors. Linker warnings as errors where you can get away with it. That's harder to enable. All of your tests run with sanitizers, like they already said. And you can get, I'm going to say, well, I know there's people who will watch this video later that'll say that I'm wrong because I interact with them on Twitter. But I'm going to say you can get 85 to 90% of the way there. So Rust, I said it out loud, doesn't have implicit conversions. If we disable as many implicit conversions as possible in C++, that gets us closer.
Which there's a clang tidy check for to force you to make single argument constructors explicit.
Right, that kind of thing, right? We have to be willing to treat C++ the same way as we treat that other language. But most C++ programmers I interact with say, I can't enable warnings as errors because that gets in my way. I can't enable -W conversion because that gets in my way. Well, if you're going to use the other language, it won't even let you convert it into a float without an explicit statement, right? I'm done with my rant.
But, I do think you bring up a good point, right? Which is just a lot of this is the defaults in C++ aren't great because history, right? However, there have been lots of innovations in tools, and the tools are constantly improving, as you can attest to, that make it so you can force those defaults with an extra step. And if you do that, and you do it rigorously, a lot of those problems go away, right? Our foundational library, it sweeps, 76 combinations of various compilers running our unit tests with different settings, sanitizer settings. But because we do that, those defects just get caught much more rapidly. And that is a huge thing to do.
Yes. One of you needs to get a conference presentation on your 76 build matrix and why, just for the record.
It's kind of just a combinatorial explosion problem, but
I understand, but
yeah. Awesome. Thank you so much for the question. And just to make sure we get to everyone else, let's move on, but really appreciate it. Thank you.
Yes, thank you for bringing that up, though. That's a good...
Yeah, hello. I'm not sure if it's relevant to that audience or to this panel, but I have more of a question about sociology and the culture of the language. Because we mentioned there is this different level of abstraction that people need to work on. There is subset of the language that get used differently by different groups. So you mentioned retype code, game code is another thing. There are people who really like the standard library and want to use it everywhere. There are companies that ban certain function of the standard library, so it could be different across company and even within a big company across project. like people like end up defining style guide or relying on like some third-party library that really change the way that you look at their code. For example, I'm thinking of Abstraction. Like is that a problem? Like, and what is the community doing to kind of have a more uniform culture across the language? Because a uniform culture across the language has kind of many advantages. Like people can answer each other questions, they can move across projects, like they can build a common understanding of the language.
Mm-hmm.
Or is that not a problem because it tends to be kind of localized to a project? It's fine for a project to adopt like a subset of the language and define their own C++ for that particular usage.
I think that's probably kind of localized to the project. Like, I mean, you see certain groups of people that tend to really like writing code in a certain way. Like, I've seen like game devs on social media, and they're quite loud about how they don't want things like range-based fors, for example. They're like, I want C with classes and a vector type, and that's it. Everything else, they're just like, I don't want that. It doesn't do anything for me. But then that seems like it's very like localized to that group of people, right? Like, I mean, it would be nice, I think, if everybody agreed on a standard way to write code, but if it's standardized within a project.
Yeah. So I think, and you brought this up at the very beginning of your class, right? Is the one interesting place to start is the C++ core guidelines, right? Which are relatively new, but they provide a really solid foundation to like start homogenizing that way of thinking a lot more. And then in the general sense, just having a very strong, building an organizational culture around like, just don't argue with the tool, but also don't make rules that you can't enforce with a tool. Yeah. Because like that's actually where most of these disagreements come from, right? It's like, I don't care actually if I have to cuddle my braces or uncuddle my braces. I care if I'm able to do it way X, and you tell me I have to do it way Y. Whereas if the tool that we all run to format and lint and style and check our code doesn't let me do it any other way, I'm just gonna say, cool, that's what I'll do, right? And so like leveraging that more is how you start up-leveling, I think, that kind of like culture to homogenize like what is idiomatic a bit more.
And thinking about your question, and even in the class that I gave this week, and this happens at every organization I'm at, I ask what standard of C++ are you using, what are your limitations? And if you have someone like at Woven, for example, who is working on code that is constrained by Misra, that is going to tightly constrain what kinds of features, what standard, what compilers they can use. And meanwhile, you have someone else at Woven that's working on tooling, and they're like, sure, I'm on writing C++ 23 code, and I can do literally anything I want to do. It's often industry and tooling pressure. Like, I'm working on this obscure architecture was dropped from the latest version of GCC. Therefore, I have to use the last version of GCC. Like, this is just the world. I don't know if there's a greater answer to that or not.
I feel like the answer this may be a cop-out, so I apologize for that, but I feel like the answer to this is standard library. It is standardization. In the ISO C++ committee, you often get people bringing proposals in saying, there's this thing that I'm using all the time that is really useful, and it's not available on some of the platforms that I want. Like, I have to sort of make my own library for this, or supporting all these platforms is a huge pain, or I just think this is useful for everyone, so I want it in the standard library. And generally speaking, by the time these things actually make it into the standard library, there are very minimal versions of their feature. They like say, make only the assumptions that you absolutely need because they've carefully stripped everything else off. And so I feel like this sort of feels to me like the answer is just everybody needs to use the standard library. But and I realize there are reasons that's difficult in certain places, but probably there should at least be subsets of it that can be used for most projects. And like, as if we're using as much standard stuff as possible, that's the best we can hope for. I mean, a lot of the reason that the C++ is more standardized from one shop to another is just there's less of it. And so people are going to have to write their own more stuff in-house in order to get the functionality that they need. I don't think that's actually better.
Thank you very much. I want to move on to the next question to make sure we get to everybody. Thank you so much.
Hello. So we had a very interesting discussion earlier about C programmer going to C++ in your classes. We had very interesting comments about C++ versus Rust and how we can use tooling to do that. And we just talked about different cultures for C++. The question I have is like, what about when we want to get lower level? For example, I work with Python developers and we do a lot of very high level stuff. And sometimes for performances reasons, for other reasons, we want to go lower. And we have also tools in front of us. We have C++, we have Rust, we have C. Like, what would you say is the advantage of C++ in a maybe general case in my situation where I have this module in Python that I want to make better. I want to go lower because I need better performances. Why would I choose C++ over something else?
I think this kind of touches on that point of like mixed declarativeness I was talking about earlier, right? Which is like, Python allows you to be very, very expressive in certain ways, right? And it pays a big performance cost for that expressiveness. But there are situations where that expressiveness is actually the thing you need, right? The limit on your development is like understanding and ability to express concepts. And if you tried to do the same thing in C++, the level of complexity of code you would need to do would be so outrageous that even if it was like really performant, like it would take you a year to write it. And like that might not actually matter for the lifetime of the like program you're going to write, right? But there might be little bits of it where it does make sense, right? And I think so part of it is really clearly understanding like what are the bits that like performance matters or some subset of type safety matters, and like you move that part down and you keep the parts that are important to keep in this place where I can move faster and be more expressive in Python. Like I would never want to have to write a command line tool in C++, right? It's a
bit of a pain.
Yeah. Whereas like that's trivial and I can do all sorts of cool, I just import click, like it's real easy. I can write a command line tool in like 5 seconds, right?
But your question was specifically why C++ instead of C or Rust when we need to go lower level?
Well, I think for like Python developers, like people use structures like lists quite a bit, and so C doesn't really have an easy way to translate that way of thinking. So at least C++ has like vector types and so on and so forth, and concepts that maybe map a bit easier to like a Python developer's Python brain, right? So at least we have a standard library, we have algorithms that you can make use of that are already there out of the box and standardized across various platforms. So that's an easier bridge to gap. And I think also people tend to use Python for like rapid prototyping stuff. Like it's really easy to just like get something going and then you're like, okay, great, I got my thing going and it does what I want, but it's like kind of slow. Okay, so now what? Like I think that C++ is pretty easy when you get used to it to like get something going too. It takes a while, but like when you have the Python code as a reference, I think it's not particularly hard to go from like
to translate.
Yeah, because like Python is kind of like pseudocode kind of. So you get like this nice pseudocode representation that can run, and then you're like, okay, now let's write the C++ on top of it. It doesn't have like the nice like command line stuff as far as I know that Python has. Like it's really easy to like write like something using argparse or something in Python. But
That's a library problem, not a language problem.
Yeah.
Well, yes, there are limits because you don't have late binding and you don't have reflection yet, and like other things.
Right. I will say, well, I don't talk about this very often, but I have about 20 years of experience with this script/C++ binding interface layer. I've written 2 of my own embedded scripting languages for C++, and I've worked a lot with SWIG, the Simplified Wrapper Interface Generator. And I know from my experience teaching that approximately 100% of C++ programmers are also Python programmers. It's not quite 100, it's very, very close to that. And on the flip side, basically 100% of Python programmers are using C++ libraries at some point. They don't know it necessarily, but the library they're using is almost certainly written in C++. So there's a lot of tooling already available here. If you don't know SWIG, for those of you who are in the audience, check it out. It does have its warts, but it has been around for a very long time, and it is very proven. And to your point about Python has a list type, C++ has a vector type, you can, with not very much effort, make a list in Python and pass it to a C++ function expecting a vector.
Yep.
And it does what you want it to do.
Yeah, while maintaining all the type safety properties and stuff.
Right.
Whereas if you just program against the C binding API, you lose all of that.
And if you don't want to use SWIG because you don't like the idea of this extra build step that it requires, you can look at something like PyBind 11 or Boost Python. Boost Python, I don't think has been maintained in a while. But you can look at those things, and the ability to say, I have a function pointer and I want to expose it to Python, because of the C++ template system, that can be a one-liner. And it can be both super efficient at compile time and at runtime in a way that is actually not possible at all in Rust or C. Rust does not have the capability to do the type of template stuff that we want to do to automatically expose a function to Python. And C, well, definitely doesn't, because it doesn't have a type system really in the same way.
Right.
So anyhow, that's my reasoning for why C++ is good at that binding layer.
Yeah. Thank you so much. I'd love to get to one or two more questions before we're out of time. Sorry, did you want to add one more thing?
I talked too much.
Yeah. Okay.
No, thank you for your question.
Thank you so much for your question. I think we have time for two more, so let's try to get to the last two people standing.
I won't answer.
Thank you for interesting speech. I have a question about the real world and the standard, because standard has very problems with the real world, because we don't have a definition of dynamic library in the standard.
Right.
And so for example, and the memory model, it's a nightmare. Sorry if you love it. Yeah. So my question is dynamic library, static destructors, and library loaded in the runtime, they'll open, they'll close, and they're in the cross-platform application. How bad is it?
Well, I don't work on the standards committee at all, so I'm just gonna bow out and say I don't have any input as to why these things aren't addressed by the standard, I guess. But cross-platform capability, dealing with that stuff, is a pain. Almost everything I've ever written is cross-platform, and I've dealt with weirdness at shared object boundaries that are the same exact code does completely different things on Windows, Linux, and Mac OS. And then it takes several weeks to sort out why.
I'm not on the standards.
Well, yeah, but you do the compiler engineering, right? So you can at least talk a little bit about why are these things kind of an issue, right? Because I'm sure Clang has to deal with the actual object model.
Not really. I'm not that experienced with that part of Clang. I'm more of a back-end person.
Yeah. So
yes, it's bad.
Yeah. Right. And so I do think that one of the it's exactly what you say, right? Is real world versus standard, right? Yeah. The standard likes to essentially pretend that there's this hypothetical machine, and anytime it brings in a concept that isn't part of that hypothetical machine, you really can risk making stuff that's hard to do across platforms that have to maintain their legacy of not doing stuff. But sometimes they can be overly beholden to that concept in a way that's not actually real, and it can get in the way. But it's a tricky thing, right? It's really hard to figure out a good balance for that kind of stuff.
And if the standard tried to specify all these things, well, first of all, it would never happen because there's already differences. And if they tried to specify it, I don't know if it would. I don't know. Other languages have been able to provide consistent behavior across operating systems.
I think it's just like one of the legacy things, right? It's like you were saying how like ABI comes up in standards committees all the time.
Yes.
The standard does not once ever mention ABI. It is not a thing that actually exists in the standard. Yet it is the justification often for like confirming or denying features. Because like in reality, the ABI is a thing. And if we change it, like stuff breaks, right? So that kind of stuff, I don't know how you, I wish I had a better answer, but yeah, it's like, it is one of the, but it, you know, it exists in C too. It's just at different boundaries because the like limits of what you can do are different.
Yeah, C has some.
Yeah.
All right. Well, we've got 4 minutes left. That's all I can say.
Oh, sorry, let's get that. Yeah, let's get that.
That was an awesome question. Thank you. It's quite a tough one as well. We'll do our last question here, so please go ahead.
It's not.
Now it's on?
Yep.
Mm-hmm.
So I'm guilty of abusing template meta programming to supplement
We
C++.
all have done it at some point.
And occasionally I even add it for fun. And my question is, how much is too much for the compiler? Because you mentioned just now that occasionally C people won't move to C++ just because of compile time.
Sometimes.
Mm-hmm.
Let's let the compiler engineer actually answer this question.
Like, how much is too much? Like, I mean, if you break the compiler, it's too much. Like, that does happen.
But there's
sometimes.
flags to increase it, right?
So yeah.
Okay, go ahead.
Go, please.
I was just going to say, so it is an interesting point that you bring up though, right? Because in C, there are pretty much only 2 errors you'll ever encounter, right? No function named this, or function named this, but it doesn't take the types you just gave me, right? When you start going into C++ with templates, suddenly that's not the span of errors you get. You might get template soup where you tried to call like an OStream operator and you get a list of 100 functions it tried that have nothing to do with the types that you just invoked, right? And that can be really confusing to C developers.
Yeah.
And so that can make them hesitant to want to move to an environment where that's like a thing that happens more. And so I think part of it is really trying to make sure that you really think about that in your API design, right? Use tricks to limit the visibility of functions for like ADL, right? Like using hidden friends for declaring operators so that they don't show up in that giant set of 100 things that it considered. Making sure you put constraints at top levels and doing customization so that like they call a function and it says, it doesn't satisfy this constraints here. I didn't see the template soup after there. I just see it didn't satisfy the constraints there.
Use concepts.
Yeah, if you have 20, yeah. Or fake them in 17 and 14 with Sphene. So I think that that's actually where a lot of that boundary is, especially between like C developers and C++ developers, is like they're scared of the errors. Like understanding what went wrong is a lot harder because you move from there are 2 errors that are very clear to there are an enormous space of errors, which unless you're very familiar with the language can often be very not clear.
Yeah, I've seen C programmers complain about that, and also like name mangling a lot.
Yeah.
Like they're just like, what is this? Why is there this giant weird function name in my object file? Like, what is this? How do I deal with it? And I think also like, if you're exposing this to other programmers as well, you're like, I want other people to work on this. Like, the more complexity you add to it, the higher the bar is for the other people working on your project as well. And that could scare people off or make it so that it's very difficult for people to work on it. So
Yeah, I think that is like the big concern with templates. Because I also love templates. I love to write them. It's fun to just like see what kinds of things you can manage to pull off in templates. One person at our company has written a regular expression parsing library that runs in templates. But like the thing that you need to do is make sure, just like Jessica said, you need to make sure that they're readable. Like errors need to be readable, but the code itself needs to be readable. And the tricks to that, I'm sure there are 1,000 different answers to this, but to me, it's about having consistent conventions so that people can learn how your code is written. And once they get used to reading your code, then they'll be able to read the next piece of your code. Unfortunately, you can do a lot that.
Also, always try breaking. If you're thinking a template, it does like a type it doesn't expect, and see what the error looks like, and like see like would I understand what this meant if I've never seen this code before, and then think about how you can improve that. And I think that can help that kind of stuff a lot.
I'm sorry to have to jump in. You want to add one last thing?
I was going to say, I know time's up.
Yeah.
You have 1 minute.
1 minute. Okay.
1 minute. If I can try to attempt to bring this whole conversation full circle, if the lowest levels of your API are const expr and template and can run on bare hardware, and you work your way up to the point where you give the user of your actual library a function that is high level enough and easy enough to use that it can be passed to your Python script, then you've accomplished something here.
Yeah.
I think this should be the goal in how we design our code.
Yeah, I agree. I think that maps to the like consistent levels of declarativeness. Right?
All right. Thank you so much. That was awesome. Thank you to everyone who got up and asked questions. I know it's really hard, but you made this event super special, so thank you so much. And a huge round of applause for our panelists for giving their time to be here today. Thank you so much. Really appreciate it. All right. So panelists, if you can move on out. Thank you. I promise that, yeah, thank you. There will be more chance to see them. We're going to move into another space and